Hey guys, for this video we're going to be looking at kinematic equations. Now they are basically the relationships between everything we learned in previous videos, so as displacement, acceleration and velocity. The good thing about them is they'll come on a formula sheet, so you don't need to actually remember, but we do need to understand how to use all of them. So that's what we're going to do this lesson by looking at some examples. So let's get into it. First equation we're going to look at is this one. Final displacement equals initial displacement plus initial velocity times time plus half times acceleration times time squared. So, got an example here. Start off really simple. Been accelerated from rest at a rate of 6 meters per second squared for 4.1 seconds. Find this final displacement. Number one thing we got to do here, really beneficial marks wise in exams, is write down the equation we're using, because that shows that we understand what we're doing. It can even be worth a mark if we write nothing else. Right. Then it's just a matter of subbing in the information we've got. So initial displacement, if it doesn't give you one, we'll just define it as 0. Initial velocity from rest means that his initial velocity was 0, took him 4.1 seconds. Is acceleration 6 meters per second squared, and the time once again 4.1 seconds squared. Now if you type that into a calculator, you'll find that is 50.43 meters that Ben travelled, and that is how we use that first equation. So moving on, second equation we're going to look at is this one. It says that the final velocity equals the initial velocity plus acceleration times time. The example I've got here, Joe is approaching a traffic light at 30 meters per second. The light turns red and Joe brakes, decelerating at 8 meters per second squared. If Joe arrives at the light in 3.4 seconds, does he stop in time? Now this one is slightly more complicated and we'll see why. So first things first, write down the equation, then we can start subbing in some values. So V0, 30 meters per second. Acceleration. Now, what a really important concept is that when the acceleration is in an opposite direction to the velocity, we actually have to reflect that in our, math. So if the velocity we've defined going forward as positive, we've actually got to define deceleration going backwards as negative. So rather than just being 8 meters per second, this is actually minus 8. And the time, 3.4 seconds. Right, chuck that into the calculator. End up with, when he reaches the light, he's still going at 2.8 meters per second. Does he stop in time? Nope. Alright, so really important, when vectors are going in opposite directions, such as acceleration and velocity, we've got to reflect that in the math that we're doing. Cool. So the last equation we're going to look at is this one. It says that the final velocity squared equals the initial velocity squared plus 2a times the final displacement minus initial displacement. Now the thing about what's in the brackets, it's really just the change in x, and it's sometimes written as that or even d for distance. So so you can see this come in a different number of forms. So the example I've got for us here, a plane has a takeoff speed of 88.3 meters per second and requires 1365 meters to reach that speed. Determine the acceleration of the plane. Right, so this is the most complicated one we've done so far. You'll see why in a second. First thing starts exactly the same way. I'm just going to write D, because they've given us a D, not final and initial displacement, so that makes it a bit easier. Right, now what are we trying to find? We're trying to find the acceleration. So we actually have to rearrange this. That's why this is the most complicated. So I'm going to subtract V0 squared off both sides. Right, then I'm going to divide by 2d to end up with just a over there. Right, now we can start subbing in our values. 1 over 2 times 1365, because that's our distance outside of VF. 88.3 squared minus V0 starts from rest, I guess. Doesn't actually say that, but we can just assume that. So that is the maths we need. Now, chuck that into the calculator, you actually end up with 2.86 meters per second squared. Right, so those are the three equations you'll find on your formula sheet. One thing I didn't mention at the beginning is that these equations only apply to questions with constant acceleration, right? So where the acceleration is changing, these equations don't apply, only with constant acceleration. And that concludes this lesson. Thanks, guys.